A fascinating discovery was made last week with new scientific research suggesting that one of the world's beloved deserts was once not so dry. I'm Janet Tchaikovsky, here with TSA News. A study led by the Max Planck Institute for Chemistry shows evidence that the Sahara-Arabian Desert, one of the driest regions on Earth and a major geographical barrier between continents, once flourished with plants and animal life almost 8 million years ago. How did that become what it is today? Fossil evidence dating back to the late Miocene and Pleistocene eras show water-dependent fauna once lived in the area, including animals like crocodiles and hippos. By analyzing limestone caves, the team was able to determine the past environment of the region, revealing that the desert used to have multiple intervals of wetter climates. These intervals likely span thousands of years each, sustaining life and enabling migration between Africa and Eurasia, our early ancestors included. These periods would be incredibly important because over time, the desert would become increasingly arid to the state we see today, as stated by Monika Markowska, one of the head researchers and first author of the scientific paper that would be published. But how did it get to this point? To really put into perspective how these discoveries were made, we sent one of our field reporters on the scene. Let's see how Harper's doing.
Hi Janet, I'm in the Wadi Snor cave in Egypt, one of the very 7 caves that researchers studied when making this discovery, and wow, it is so cold and dark in here. Right above me, you can see some stalagmites hanging from the cave roof, a key factor in scientists' discovery. You see, the chemical composition of limestone changes drastically based on the surrounding temperatures through a process called calcination, where the rock's calcium carbonate begins to break down. Stalactites form when rainwater seeps through the soil into the cave, dissolving the calcium carbonate and over the years crystallizing layer by layer to form the stalactites you see today. When you crack these formations open, it reveals a tree stump-like rings that scientists could analyze for temperature and precipitation patterns. The research team used radiometric dating to determine the age of the limestone, looking at the radioactive decay of uranium isotopes carried into the cave by water. By analyzing the oxygen and hydrogen composition of fossilized water in these stalactites, evidence suggests that the rain likely came from monsoons coming from the south. Monsoons that would later start moving further and further south due to the cooling of the northern hemisphere. This slow absence of rainfall eventually resulted in the desert we see today.
Oh boy, it's amazing that we can find geographical location by analyzing water's chemical composition. So looking at the bigger picture, why does all this matter? Well, this new research is reshaping theories on how our early human ancestors were able to traverse between the African and Eurasian continents, rewriting our previous knowledge about human migration routes and making the Sahara-Arabian Desert a key crossroad.
It's easy to think what happens in the past stays in the past, but this discovery is also a flashing warning sign for all of us about the impacts of climate change on our world. Even slight shifts in weather pattern can cause drastic changes to our sensitive climates, impacting not just the landscape, but ecosystems, wildlife, and our day-to-day lives. Climate change is a devastating but very real problem that we are facing today. It's crucial that we continue to learn more about the past in order to create a better future.
Thank you, Harper. I'm Janet Tchaikovsky, and thank you for your time. We'll be back tomorrow with the morning news.